Welcome everyone to yet another exciting Moralis video. In this video, I'm going to show you our new wallet history API that you can use to very quickly build powerful wallet history features in your wallet application or portfolio manager or any other type of crypto application where you need to figure out what a wallet has done in its history. And it's super easy, and the end result for this demo is going to look something like this, where you can specify a wallet, and not only do you get the net worth of the wallet, you can do a chain selector, but you get this nice wallet history. You can see received a token from this address, sent 1 USDC to this address. You can see signed a transaction, borrowed 5 Matic from this address, minted 2 NFTs, minted 1 NFT. And this comes all out of the API. I've done no interpretation logic in order to get these nice descriptions. And it all comes out of this, the Moralis get wallet history endpoint, which just launched as of recording this. And for the address that you query, you get a very detailed response, including everything that happened in this transaction. If it's an ERC20 transfer or an ERC20 transaction, like a swap or something, you'll get all of the details in that array. If it was an NFT related transaction, you'll get all of that in the NFT transfers array. It covers also internal transactions, native transactions, all in one endpoint. And you get these nice summaries that we saw in the application where you sent a certain amount of tokens to a specific address. It also has address labels. You can see here, Uniswap Universal Router, where you get it by default, where you can see where did this transaction go when it went to Uniswap. And that allows you to build something like this very, very easily. It's super powerful. It covers everything from swaps, transfers of ERC20 tokens, of native transfers. It covers things like if you interact with DeFi, like you borrowed 5 Matic from some protocol, you deposit into Aave, you swap tokens, you mint NFTs. Everything is basically covered in this API, and it's super easy to use. And in this video, I'll show you all of that. I'll show you how we build this wallet history feature, and I'll walk you through it step by step. You'll find the code in order to get started in the comment section below with like a boilerplate for how to get started, as well as the finished code of where we end up. You will need a Moralis account, which you can get for free over at moralis.io. Sign up for that, get your API key. That's basically it. If you enjoy these types of videos, make sure to hit the like button. It really helps, and subscribe to the channel. Let's get into it. All right, we're going to start over here at my GitHub, where you'll find the starting point of this tutorial. And that's going to work like a boilerplate where we have the basic structure of this portfolio app ready. And if you followed some of the other older portfolio demo videos that I've done, it's basically based on that old portfolio demo. So go to the GitHub link down below for the starting point, and make sure that you well, that will be in the terminal in a little bit, but we're going to check out the wallet history start branch. That's going to be important. That's where this starting point is. And you can also see the finished wallet history. That's going to be linked also down below, but that's the branch for the finished code. But the starting point contains some of the basic structure and also some like helper components that are quite simple but takes time to build, so that we're not going to spend too much time on that. Instead, we're going to focus on the important pieces of code. So you're going to want to clone this repository. So you click the code tab here, you copy, at least for me, the HTTPS URL there. And then we're going to go into the terminal. And I'm going to use my Visual Studio Code terminal. And then I'm going to go into my downloads folder. And here I'm going to do git clone this repository. You can do this in whatever directory you want, of course. That will clone into Moralis portfolio demo. I'm going to go into that directory. And here we're going to run, or sorry, maybe I should make this a little bit bigger. There we go. I'm going to do git checkout, and then we're going to check out the starting branch, and that was wallet history start. Wallet-history-start. All right. And then we have checked out that branch. And then I'm going to open that folder. So now we're in the wallet history Moralis portfolio demo folder, and on the wallet history start branch that we've checked out. And we can just confirm this git status on branch wallet history start. This is going to be important. And then we're going to run npm install to make sure that we install all of the packages that we are depending on here. And we'll let that run here for a little bit. There we go. And the other setup you need to do is you need to make sure that in the .env file that you add your Moralis API key or API secret. And for that, we need to go to admin.moralis.io. And you're going to want to sign in here into your Moralis account. And you're going to want to find your API key here on the start page. You can copy that and add into the file. You can also find all your API keys in settings. And here are the API keys. You want to paste that in here and then save. And then we can start working on this. And to get an overview of the structure, which is similar, by the way, to the portfolio app that I've done a video about in the past, app.js is just very simple. We have, which is different from, I think, the last tutorial, I've set up a routes component so that we can route different paths in the URL. But for now, any path will route to the portfolio component. And the portfolio component can be found inside pages / portfolio. And here you'll find portfolio.js. And this one is slightly more complex. Here we have the logic for selecting the chains. And we have, well, by the way, we can check this, like what this looks like before, so you get an idea of that as well. We'll run npm start in the terminal. We'll fire this project up. Make sure that you've added the API key and save that. So we're gonna show you the functionality, and then I'll also then walk you through the current code that we have here. And where we're gonna be working is in this history table. So there's a file called history table, which is now empty. That's where we're gonna do most of our logic here. Let's see if that starts up here in a second. There we go. So this is our base portfolio app, like the baseline. And here we'll find all of the assets of a wallet that I've inputted here. This is just a default wallet. Here we have all of the assets, all of the prices and value, 24-hour change. And we can toggle the different chains to select which chain we want to display assets from. This is a little bit slow because the logic for it is not really ideal. We fetch it from the API every single time, but it does work. And so some of these components, we also have the net worth of the wallet up here. And if we check out this portfolio component, we can see what is, let's see. Okay. We can see what is going on here. So we have this selected change, which keeps track of our chain selection. We have the default address, which you can change, by the way. We're going to change it later, I think. We have, the address. We have the net worth. And then we have different functions for fetching the net worth from Moralis, which is the net worth endpoint. We're going to return this piece of HTML, which contains the input for the address, the button for setting the address and fetching the assets, the net worth component, which you can check out if you want, it's over here, and the chain selector component. And finally, a route component, which we're going to use in order to, depending on the route in the URL, meaning the slash, whatever comes after the URL, we're going to render a different component down here. So now we have this asset table. That's where we're also going to add the history table, so that if we go to /history, we're going to show the timeline of that wallet instead of showing the assets. So you can think about this as like different tabs in the UI. So that's what we're going to do up next. We're going to add a route we can copy this and just paste it down below. We're going to have /history. And instead of showing the element as the asset table, we're going to show the history table, which I've already created a file for. So just history table, and we're going to have the same, address input and selected chains, because the wallet history, of course, also depends on the address and on the selected chains. And then in history table, we can go in here and just we can copy over this React stuff. We're going to need that, and then we do function history table, and that's going to take an object with selected chains. Let's see, selected chains and address. And then at the end of it, we're going to, just like in portfolio, export default, but this time history table. Oops. And then from this function, we can return some basic HTML. So we'll return, let's say div, and in here we can just say history. Okay, and we can see if it renders. That seems to work. We'll go to /history because that's how we set up the route. And we do get history. So our routing works and our initial component works. So now we just got to add the logic for fetching the history and displaying it as a nice list. And you'll see how easy this is with the new Moralis wallet history endpoint. So first of all, we're going to need to add some state logic in order to save the actual history of this wallet. So it's going to be history and set history. Use state, and to begin with, it's just going to be an empty array. But here is where we'll get all of those historic events like deposit, withdrawals, transfers, swaps, and so on. And then we're going to need a function to fetch history. And for this, in here, we're going to, of course, use Moralis to fetch it. And for that, we're going to go to Moralis docs and check out how to fetch the history using the history endpoint. So go to docs.moralis.io, go to the Web3 data API, wallet API, and then wallet history. Get wallet history. This is the endpoint that you're looking for. And in this case, we're just using the just going to use the endpoint with the fetch in JavaScript. So we're not going to use the Node.js SDK. I'm not sure if it works in React or not, actually. Maybe it does, but we can use the fetch function in JavaScript to fetch it using just the URL. That's, I believe I did that in the portfolio as well. So we're going to copy this URL and we'll go back to our code. And so we'll put here our base URL will be equal to this string. We're going to remove the query parameters and the address. So that is our base URL. And then we're going to have an address. Well, our address comes already from here, but we're going to have some query parameters, query params. That is going to be equal to, let's see here, question mark chain is equal to, so here we're running into the first problem, right? We're going to fetch multi-chain, which means that this endpoint is going to have to be called once per each chain. So we're going to have a chain param here, which is going to basically be every chain that is in the selected chains array. So question mark chain is going to be equal to chain. And then we're also going to have a parameter for, whoops, that needs to be inside of there. Where is my, there we go. We also have a parameter that's called from date. If you look at docs, you can see that there are some parameters here, from block, from date, which means that we can specify how far back in history do you want to go. Do you want to go back, 7 days, 30 days, 365 days? And here we're going to specify a date later on that we're going to use. We'll also get this from our input here. So we'll do a from date parameter, which we can specify later how far back we want to go. And then we can also specify the order, which is going to be descending, meaning that we get the most recent event first. Finally, we're also going to, well, let's see here. Do you need NFT metadata? Because we can specify NFT metadata true, and that will also include the NFT metadata by default. But I don't think we're going to use that, so we can skip that one, and the response time will be a little bit faster. But you can get NFT metadata already in the same response. We'll not include that now. We'll see if we build that later. And also, if, well, let's see here. We'll do this later because we're going to need to add some logic for the cursor, meaning that if there's multiple pages that we need to fetch, we're going to need to use a cursor and attach that here. But we will do that later. From here then, we're going to put together the URL. So const URL is going to be equal to base URL. Well, let's do this like this. Base URL. Let's actually, we'll remove that slash from there. So we'll end with wallets, no slash, and then we'll put slash here, followed by the address. Because that was the URL structure, if you remember from docs, we have wallets slash the address and then slash history followed by the query parameters. So we have slash address slash history, and then we have the query parameters, query params, like so. So that's going to be our URL. We'll move that up, and then we're going to return fetch with the URL. And let's see, do we need headers? Yeah, we need headers also. And we can put them, I guess, also here. So we'll do const headers, and that's going to be content type application slash JSON, and then x-api-key, like so. And that we're going to grab from our process.env slash or .react underscore. Check the env here. Copy that. There we go. React app Moralis API key. That is going to be our headers, and we'll include that into our fetch call. Important, otherwise this call is not going to work. Then we can run our fetch, and then when we get the response, data, we'll just console log the data. We'll see if it works. Okay. So now we've defined our function. Now we also need to call the function. So after we've defined it here, we're going to call fetch history, and then we have to specify the chain. For now, just write ETH, but then we're going to have to build the logic to do this for each chain. And from date, we're going to have to specify a date. So, all right, so we'll create a date object here. Const today is equal to new date, because what I want to do here is I want to create a date that is 30 days from today, like back in time. So we fetch 30 days of history, and then we'll set the from date, as a new date, but we'll base it on today.setDate, and what we're gonna do today.getDate minus 30. So this is going to create a new date object based on a date that is 30 days from today, or before today. And then we can input that from date here as our from date, and that should be it. So fetch history, that console logs the data. These three lines should be inside of our use effects function. So use effect, because that will run this when the page loads. And let's see here. And we do have a dependency here on the address and on the selected chains. We'll save that, and looks like it's working. We're going to console log that. Okay, let's see if we actually get it. Response, body. Okay, so we're going to have to parse this response here before we can look at it in the console. And to do that, we're going to do data dot JSON as a function, and that should get us the body as a JSON object. Let's see here. Promise. So this is a, let's see here. Return data.json. This is a promise, and then we can do .then with JSON, and then here we can console log JSON. There we go. Now we get some objects here with some results, and this is going to be our history. Oops, let me make this bigger. There we go. So we get an array with these events, and this is the history. You can see the timestamp of this. You can see what happened. It's a token send. You can see for the from address. You can see the to address. You can even see the to address label, right? So this was a token send to the address of the USDC coin. And if there were, for example, any ERC20 transfers, you can see that in this array. And there was a send of USDC, and there's no native transfer, there's no NFT transfer. if there was, for example, a swap, you would see that in the category, and you would see either 2 tokens in the ERC20 transfers array, or you would see 1 token in the ERC20 transfers array and 1 native transfer if you swap, for example, ETH to a token. And we can watch a few more here. We have a deposit, which is then you deposit it into some kind of protocol. So here the Aave lending pool v2. You can see a contract interaction where we just sign the transaction. You can see a mint. So you can see plenty of activities here, and you get a nice summary. Minted 2 NFTs, signed the transaction, deposited 0.01 what is that? Aave staked ETH. So quite comprehensive. And now we can create a way to display this history on the page. And then we're also going to have to figure out how to do this for all of the chains and for all of the pages that might exist. And to start with that, we're going to need to use our history property here to set the data into this state variable instead of just console logging it like we do here. And if we take a look at the data again, open up the terminal, and let's see here. We are now console logging this whole object, but what we're really interested in is the results array. So it's the JSON object.results that we want to add into our history, and then we can render all of these on the page. We're not interested in this stuff to render on the page. So what we're going to do is we're going to call set history with JSON.result. And when we've done that, then we're also going to need to edit our HTML to make sure that we actually render everything that is in the history object. And this is not too difficult. We're going to map all of the history elements. So history, we'll do $.map so that if it is not defined, which it won't be when we load the page, it's not going to throw a bunch of errors. So for each of the history events, whatever you want to call it, we can call it events. We're going to we'll call it every entry, so like history entry, and then we'll also have an index for each one in the array. And then for each of these entries, we're going to well, for now we can just let's say we do a div here, and inside of here we'll just do entry dot what do we have here? We have something like block number. We'll take that and just see if this mapping here actually works. There we go. Now we're writing out all of the block numbers, or we can do something more fun actually. We could write out like the summary, let's say. There you go, sent 1 USDC, deposited, signed transaction, minted 2 NFTs, deposited, that all works great. So this is basically the full history for 30 days for this address, but it's very ugly and it doesn't contain a lot of detail. And it's also incomplete because we're only fetching the ETH chain now. But we're going to fix all of that. But you can see that it's already working quite well. To make this a little bit faster so that we don't have to spend too much time on styling and so on, I have created inside of the components directory, I've created something called table row together with tablerow.css, some basic styling for this. And the table row is basically a single row component that has a kind of accordion style div element to it, where we will display things like the date, we'll display an icon, we're going to do the summary, which is what we just printed, event.summary. And we also, if we have clicked on this accordion, we have expanded the transaction details, which is another object that contains things like transaction hash, from, and to. So this makes it a bit quicker to write out all of the details, because all we can do here is just to create a table row element and pass in, as I call it event here, it will pass in the entry, as that, and then also the index. Like so. And this is going to make a big difference, because now when we open the page, all of a sudden we have all of this, right? Which is really the same thing as we did before. Sent 1 USDC, deposited this, signed a transaction, but I've only added some styling to it. So I've made them full width, I've created a border around them, I printed the date, and I've added an icon for each event. So if it's something that's sent, it's going to be an arrow out. If it's something received, which we don't have here, it's going to be an arrow in the other direction. If it's a swap, I have this swap icon. I've added these logos. You can see what I swapped. We swapped DAI for ETH. Here we swapped ETH for staked ETH. So that was a quick win here. And if you want to check out this logic in more detail, you can do that in the table row, where we have things like the history icon, which really is just checking the category of the event. And if it's a send, it has a specific SVG. If it's a deposit, receive, withdraw, airdrop, mint, burn, NFT receive, NFT send, token receive, NFT purchase, NFT sale, token swap, approve, borrow, contract interaction. We have different icons for all of these, and we just return that as an SVG element. That is what creates all of this. And you can see all of these categories here for in the category property. And apart from that, in the history table row, you also have swap logos, which is, I mean, a really simple thing where we just take and print out two logos for the asset, which you can see here. If there's a swap, we'll take the token logo from the event, which also is here. So we do have here event ERC20 transfers .token logo that do exist in all of these. Token logo, you have that in the response here as well. So it looks a bit complex, this code, but it's really, really simple. I just check if the ERC20 transfer has a length of 2. If so, it's pretty easy. We just take those two transfer events, we take the token logos for both of them. But there might be a case where you have a native transfer swap. So ERC20.transfers.length is 1, and the native transfers length is also 1. Then we get the token logo from the ERC20 array, and we get the native transfer logo, which is going to be ETH, BNB, and so on. So you can study this in more detail if you're interested, but it is so that we can move a bit quicker here and not spend too much time on the styling. This also enables us to click on this to expand them and to get a bit more detail on all of these items. The transaction hash here, you can of course link to Etherscan if you want to do that. You can see the from address, the to address, and so on. I did see that we got a warning here that each child in a list should have a unique key property. We can add that to just get rid of the error. That's going to be in the, let's see, table row. Can we add it here? Maybe key is going to be index. That should get rid of that warning. Yes, and that is to help React know it needs to be a unique key for each row, and that helps React know which element has been rendered and which has not been. Then what's left to do now is to figure out this whole thing with the chain, so that we fetch from multiple chains. We can start with that. Then we also got to figure out how we fetch all of the pages. So if we request a wallet which has a lot of events, Moralis is just going to respond in pages of 100 events in each. And that means that if there is more than 100 for a specific chain for a specific time period, we need to call it with the cursor to get more pages. And I'll show you that in a while as well. But let's start with making sure that we get all of the chains that are selected in our selected chains array. So this is going to mean that for each chain in the selected chains array, we're going to have to call the fetch history function. So we're going to do a map call here. And we do a map call because we want all of these fetch history calls to return a promise, which we'll put in an array. So what should we call this? We can call it promises. And we're going to map over the selected chains. Where we'll call fetch history. Did we call it that? Yeah. For each of the chains. So we'll call chain. We'll add that, and then the from date, which is here. And this will create an array. I'll do const promises. This will create an array of promises where we can then do const results is equal to promises, await promise dot all. And we'll pass in the array of promises there. And then after that, we can console log the results. And instead then, we're also going to need to change the structure here a bit, but also this new structure expects us to return all of the results here. So instead of console logging here and setting history here, we're just going to be return JSON dot results. And then we're gonna rename this fetch history for chain. Fetch history for chain, because then we're gonna take all of this and we're gonna add this into a function here, and we'll call this fetch history. And this is going to be an async function, and we'll throw all of this stuff in here, and then down here we're gonna call fetch history. We're waiting for all of the promises to resolve, and fetch history. That's going to be fetch history for chain. There we go. And that gives us the result. We're waiting for all of the results. So this will be an array now. We'll see that. This will be an array of arrays for each chain. Oh, wait. This we shouldn't even have. That was a mistake. We just need to call fetch history for chain here for each of the chains. Let's try that and see if we got it right. All of them are undefined. Let's see what we did wrong. Oh, there was that. It's not called. It's called JSON.results. Here we call it results. It's confusing. So now we get arrays with the actual history. So now this object contains arrays for each chain. So this maybe is ETH, this maybe is Polygon, this is BNB chain, this is Optimism, this is Base. We don't know that now because we don't necessarily know the order, and we didn't mark these in any way. So we have a few things to do here. Number one, we could mark each of the objects with the chain parameter. But for our little history thing here, as it doesn't matter, but I think if you want to do it the correct way, we should mark them with the chain. So let's do that, because you might want to link to different token explorers, like the chain ID, the transaction hash is only valid for the specific chain. So we need to know which chain it is if we want to continue to build on this. So that's going to be important that we know, because at the end of the day, we want to merge these into one array, but we want to know, because we want one timeline, right? We don't want 5 different timelines. So we want all of them to be in one array in order, and we want to know which event was on which chain. So how can we know that? Well, when we fetched it, we do know the chain. So we can modify the data in order to mark each object with the actual chain parameter. And we can do that here. So once we've got the JSON data, we can get all of the events by calling JSON.result.map. And so for each event here in the array that we get back for each chain, we can call, or sorry, not call, but we can return the full object. So we do ... event, but then we'll add chain is equal to chain. So we'll take the parameter from here, and we'll extend this object. So this ... notion basically takes the entire event object, we add another parameter, chain, and return that as a full object. That is now the new modified events structure, and then we can return the events. So now if we look at the array, for each of these, we'll now also have chain ETH. And if we look at the second array, we'll have chain Polygon. So that will help us. Now, the last thing we need to do here is to make sure that these need to be one array, and it needs to be sorted. So now each of these arrays are sorted in descending order, because we got it from Moralis in that way. But now we want one timeline, because we only have one history object, right? And we use the one history object to render these rows. So we need one array with all events in ordered form, okay? So that means that when we get them back here, before we set them to the history object, we need to merge them into one array and then sort them. So first of all, how do we get them into a single array? Well, we use a function, it's called flat. So combined result is equal to results.flat. Okay, that, if we console log that, we'll bring all of these into one single array, okay? Where the chain parameter will be in each object, ETH. Check on here, it's going to be optimism. So now they're all in one array. But now, because they're just stacked on top of each other, they're not in order. Each individual chain is going to be in order in that array, but not the whole array. So we're also going to need to sort them. So we'll do that in the same line here, basically. We'll do dot sort, and then it will look at two elements. So this is how you write the sort, the JavaScript sort algorithm. It will look at element A and B, and then we're going to define a function for how we compare them. And to do that, we're going to need to look at the timestamp. We're going to be looking at the block timestamp. But in order to be able to compare the timestamp of one event to the next, we're going to need to create a date object. So new date from, we'll do b.block_timestamp first. And we'll subtract that with a new date object of a.block_timestamp. And what this will do is that it will compare the value of b block timestamp to a block timestamp. And what this does is that it compares these two timestamps, and if one of them is bigger than the other, it will swap them. And if the order is wrong, you can just flip these two statements. You can have A over here and B over here, because I'm the same. I never remember, like, should it be positive or negative? You just try one, you compare one to the next using subtraction. And if the order is wrong, then you just switch them. And this is now the order that we want. One other trick here, which is going to be important if you're viewing this app with a large wallet. You're also going to want to filter this array to remove spam. And you can do that out of the box with Moralis. So we're going to look at the event, and we're going to make sure that event.possible_spam is equal to false. So we only want to pass through results into this combined results array if possible spam is equal to false. Then we will sort it, and then we'll console log the combined results. And now if you check on the array again, you can see we have fewer results now. Previously we had 56, now we'll have 33 because we removed the spam. So now let's check if the sorting is correct. We have April 6th, which was 2 days ago. This was on base. Then we get April 4th on ETH. Then we get March 29 on ETH. So now the result is mixed with chains, but the ordering is now also complete across all of the chains. It's not just ETH, 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 then Polygon, then Base, etc., or BNB. It's now mixed, but it's in the right order. And we have removed the spam. Important. So now we can set this to our history state variable instead of just console logging it. We can do set history using combined results. And this will now render the full result across all of these different chains. And this also means that if I remove a chain now, that will refetch the history and change it out of the box, because we have that dependency on the combined, on the selected chains. And that comes for free basically from our previous portfolio building experience, if you did do that video with me. One thing that is missing from this now is that there is no notion of which chain this is on in the actual UI. We have that on each of the objects, but we don't display it in the UI, and that can be good to do. So we're going to go into the history table, and we can do show this by modifying the table row, and then we maybe want to have it inside of this transaction details. So we go into transaction details, and here we can add a div here at the top, which just says chain. It will be event.chain. This will add chain here, base, ETH, Polygon. You can of course improve this and make it way more pretty by writing out maybe the full name instead of just ETH, or you could add a logo for the chain. We do have, I believe, chain logos. Yeah, we do have chain logos. You could improve that a lot. But this is just to show the actual functionality that we do have this data. And functionality-wise, the only thing that's missing now is if we're creating a large wallet that has more than 100 events on a single chain, we're just doing one call per chain. And if there's more than 100 events in your given time span, now 30 days, it's only going to fetch the first 100 for each chain. I can showcase this by fetching a large wallet, and then we're going to make sure that we fix it. So if you now want to look at the limitation here of using Vitalik's wallet, we just need to console log the results array here to get the results per chain. So before we merge it, we're going to console log results. So if I input a massive wallet here, now I'm inputting Vitalik's wallet, which you can just find by Googling vitalik.eth. So let's fetch those assets, and you'll see the limitation. Oh, let's see. That's the full array. Here is the per chain array. And you see that for ETH, it maxes out at 100. And this is for ETH, yeah. And probably for, what is this, Polygon, maxes out at 100. Same for BNB chain. And then for a chain with not as much activity, like what is this, Optimism, it fetches them all because it's 44. But for the other, they're capped out at 100, even though there's way more events than 100. And you'll see this later on when we actually fix this issue. But for now, we remove this, and let's get into actually fixing that. In order to get all of the events, we need to use the, cursor. That we do get if the response is larger than 100, this cursor element would be set, and we can use that to fetch the next page. So that's what we're going to have to implement now, that we continue to fetch pages until there are no more pages to fetch. And this requires a little bit more of a complex fetch operation, where we either loop through and calls the function until there is no more cursor, basically, or we do a recursive setup where we have a function that calls itself over and over again until there is no cursor. Then we have to combine the results from all of these calls for a specific chain, and then eventually we'll combine them from across all of the different chains, just like we do today. What we're going to do here inside is to modify this fetch history for chain function. And we're going to add and put most of the stuff. We can have the base URL at the top. The query param, let's see here. This is going to have to be inside. All of the rest is going to have to be inside another function, which we will call fetch page. This is going to take a cursor element, and for default, it will be an empty string. And we'll put all of this stuff inside of this new fetch page function. So now I have a function in a function. And this just defines the function. It doesn't call the function. It only calls the function if we do fetch page, like so. Just defining it like this doesn't actually call it, but we will be calling it. But we just need to define it first. And for each fetch history for chain call that we do, we're going to be calling the fetch page function until there are no more pages. But so inside of fetch page here, if there is a cursor present, in the first time we call this, there will not be any cursor. But maybe when we look at the response and we see a cursor, we're going to call this again and input the cursor as an input. So if there is a cursor, we're going to want to modify the query params. So that query params, we're going to do plus equal. So we add something to it. We're going to be adding and cursor equal to cursor. Okay. And then that's going to be attached to the URL when we add the query params here. But of course, if there's no cursor present, meaning it's empty, then it will not add it, and it will be just like a normal call. And that will happen every first call that we make. Okay. And the last thing we need to do is inside of this, basically the last part of the function, once we have decoded the JSON and we've gotten all of the events, instead of returning just the events here, we're going to be adding these events into an array at the top of this function. So we're going to have an array here, all events, that's equal to an empty array. Oh, well, it cannot be a constant because we're going to modify it. Let all events be equal to an array. And then what we're going to do here is we're going to do all events dot concat, which means we're going to merge two arrays. We'll be merging the all events array with the events array. And I believe that concat, which is short for concatenate, I think. My English is not, the best. It's not my first language. This creates a copy of the array. So we're going to have to set all events equal to all events dot concat. And before we return, we're going to check if, well, we can remove this for now. I'm going to check if in the actual result, which would be JSON here, if there is a cursor. If JSON.cursor, which is, if you look at the docs, is this thing. If there is a cursor here, an empty string would be false. So if there is a cursor here, we're going to return, not the result, but we're going to return fetch page as a call. So we call it again with JSON.cursor. Okay? And then that will now just keep calling until there is no cursor. So what happens when there is no cursor? Well, then we're just going to return all events. So what we've done, as long as this keeps calling itself with the new cursor, it keeps on adding events into the all events array. And it needs like an exit point. And what's the exit point? When there is no more cursor, then we want to return all of the events. Okay? And all that's needs to be done now is that now we've defined this function inside of the fetch history for chain function, which we're already calling, but we're not calling the fetch page function yet. So that we need to do at the very bottom here. We're going to be calling fetch page. And when we do the first call, we don't have any cursor. We're just going to leave that empty. And this is what we're going to be returning. We're going to be returning this fetch page call, which in turn, once it's done, will return all events. And here we can add some error handling. So we can do .catch if anything fails here. Do console.error. Error fetching for chain. Chain. And we'll add the error. Okay, let's see. We got one error in the console now. Compilation error. All event is not defined, so I misspelled something. All events, there we go. This should now mean that we do fetch all of the entries, all of the events, all of the pages for all of the chains, because the same thing still applies. Once we have fetched for a chain, that is being merged here later on in fetch history function. Okay, we already combined the results here. So now, let's see here. Now we should be getting, oh, now we didn't have the Vitalik wallet anymore. Let's get Vitalik's wallet in here. But it's a good sign that it's actually still working. But for this small wallet, it wouldn't make a difference. We still get just 33 events. Let's see for Vitalik's wallet. Whoops. Assignment to constant variable. History table 14. What did we screw up? Oh, query params is a constant. That cannot be a constant. I need to change that. We could also just change the URL, but it would be the same thing. We would need to change the constant. So we change that to just be let query params. Let's try again. And we're going to need to input Vitalik's wallet, fetch assets. Takes a long time now because Vitalik does have a massive wallet. There we go. We have 1,500 events this time. And now you can see that we got way more than 100. So this means now that we're fetching all of the pages for all of the chains so that we get the full history view. And that basically now completes the wallet history. For someone like Vitalik, this doesn't look too nice because a wallet like Vitalik's public wallet gets a lot of deposits of these crap shit meme coins. So the wallet history is very busy and with tokens without logos, things like that. And if we do our more normal wallet here, you can see it looks a lot more healthy. And you could try with your own wallet. Make sure that if you don't have any activity in the past 30 days, you need to change that. Where did we do that? In the portfolio or in the history table? Yeah, when we did the date here, we put 30. You could add this, well, you should probably add this as a parameter into your UI where you can specify which time period you want to look at. And this wraps up the basic implementation of wallet history. Now, there are many, many improvements you can make to this. And I'll give some suggestions here. As I said before, you could improve so that you display the chain in a nice way, where maybe it's a logo. You can use the chain logos that we already have, right? You can link to the right block explorer for different chains and different transaction hashes. you can include like NFT metadata. If there's an NFT mint here, for example, you could include the NFT metadata by using the flag include NFT metadata, or NFT metadata is true. Okay, that's how you would pass it in, like this here. Okay, that's a big improvement. You could also improve the speed of the chain selector so that you don't refetch the history for each of the chains that you select, but maybe only display or hide the actual assets. So you only fetch once and then you display and you hide. Another thing that would make this portfolio app a lot better is to add navigation. So because now we just have to type in /history in order to get to the history page. If we go back to the base path, you still see the portfolio, and we need to type /history in order to go to the history page. You could add a menu or a tab or something, or you can switch between the different paths, okay? That would be an improvement, right? Or you could just change the routing as a whole, so maybe that you don't even use routes, but you fetch all of the data, and then you can toggle between different pages, just display and hide different components. Depends on how you want to build it. That's a big improvement. You could maybe save the history of different wallets, so you can like click on different wallets. You could segregate this in a nicer way by date or month or chain. There's so many improvements that you could make to this. This is just an example of what you can do and how quickly you can do it with the history API. And what's especially powerful, which you will not find in any other API like this, is the summary you get by default. Like sent 1 USD, deposited this and this, signed a transaction, borrowed 5 Matic. It's so easy to make nice history, wallet history with this. So I hope that you go on and improve this, not only with the functionality, but also please with the looks, make it look better than this. And yeah, maybe you can show me yours or link me yours down in the comments below. And if you do have any questions, please leave them down in the comment section below, and me and our team will be able to help you there. If you enjoy this type of video, make sure to hit the like button, subscribe to the channel, and follow the links in the description in order to sign up for Moralis account, in order to get the links to the finished code and to the start of the boilerplate. And if you get stuck, yeah, as I said, leave a comment down below. You can also go into our Discord, links down below, get help there from our community and from our moderators, from our team. I hope you enjoyed this video, and I'll see you in the next one. Thank you.